Hello everyone, welcome to another episode of Deep Dive Knowledge Talk. Hello, I see you're interested in the DSPy framework. I'd love to learn more about the technical aspects of how DSPy works and its significance in the generative AI community. Could you provide some insights into the purpose behind developing DSPy and how it addresses the prompting sensitivity problem?
DSPy, which stands for Declarative Self-Improving Language Programs in Python, is a framework created by researchers at Stanford NLP. It focuses on programming with foundation models, like language models, LMs, to build LLM-based applications more robustly. The main goal of DSPy is to shift the emphasis from manipulating prompts towards programming, thereby tackling the fragility issue in LM-based applications. Traditional prompt engineering methods are replaced in DSPy with three key concepts: signatures, modules, and teleprompters. Signatures take the place of handwritten prompts, modules replace specific prompt engineering techniques, and teleprompters automate the manual process of prompt engineering iterations. By using DSPy, developers can separate the information flow of their program from the parameters of each step, and the framework can automatically optimize how to prompt or fine-tune LMs for specific tasks. This systematic approach streamlines the development process and minimizes the sensitivity of the system to different prompts, making LM-based applications more reliable and easier to build.
That's fascinating. It seems like DSPy offers a more structured and systematic way to develop LM-based applications, moving away from manual prompt engineering towards a more programmatic approach. The concepts of signatures, modules, and teleprompters play crucial roles in automating and optimizing the prompting process within the framework. By prioritizing programming over prompt manipulation, DSPy aims to enhance the robustness and reliability of LM-based applications. Could you delve deeper into how DSPy specifically utilizes these concepts to improve the development workflow and reduce sensitivity to prompt variations in LM-based applications?
DSPy uses the concepts of signatures, modules, and teleprompters to make developing LM-based applications smoother and less sensitive to changes in prompts. Here's how it works. 1. Signatures. In DSPy, every interaction with the language model LM requires a signature. This signature is like a recipe that tells the LM what to do, without getting into the nitty-gritty details of how to ask for information. So instead of manually crafting prompts, developers use these concise signatures to communicate with the LM effectively. This helps separate the logic of the program from the specific prompts used, making the system more robust against changes in prompts. 2. Modules. DSPy provides modules that encapsulate different prompting techniques such as chain of thought or React. These modules act like tools that developers can use to adapt the signatures to specific tasks. By abstracting prompting techniques into modules, DSPy allows for more flexibility and automation in adjusting prompts, fine-tuning, augmenting, and reasoning within the application. 3. Teleprompters. Teleprompters in DSPy automate the manual process of prompt engineering. They optimize the prompts used in the application, making it easier for developers to fine-tune the LM without having to tweak prompts manually. By automating this process, teleprompters help in improving the efficiency of the development workflow and reduce the sensitivity of the application to variations in prompts. By combining signatures for clear communication with the LM, modules for flexible adaptation of prompting techniques, and teleprompters for automated prompt optimization, DSPy streamlines the development process and minimizes the impact of prompt changes on LM-based applications.
It's fascinating to see how DSPy integrates the concepts of signatures, modules, and teleprompters to enhance the development of LM-based applications. Signatures serve as concise instructions for interacting with the language model, allowing developers to communicate effectively without delving into the specifics of crafting prompts. Modules encapsulate prompting techniques, providing flexibility and automation in adapting signatures to different tasks. Additionally, teleprompters automate prompt optimization, streamlining the fine-tuning process and reducing sensitivity to prompt variations. By leveraging these concepts, DSPy not only simplifies the development workflow, but also increases the resilience of LM-based applications to changes in prompts. This structured and automated approach marks a significant shift from traditional prompt engineering methods emphasizing programming and efficiency in building robust LM applications.
DSPy integrates the concepts of signatures, modules, and teleprompters to enhance the development of LM-based applications by simplifying the process and reducing sensitivity to prompt variations. Firstly, signatures in DSPy act as a replacement for handwritten prompts. They are like a little recipe that tells the language model what kind of input it will receive and what kind of output it should give. For example, a signature could be question-answer, indicating that the model should take a question and provide an answer. This abstraction helps in focusing more on programming the logic rather than fine-tuning prompts. Secondly, modules in DSPy are used to abstract various prompting techniques like chain of thought or React. These modules are like tools that can be customized and applied to adapt the signatures to different tasks by adjusting prompting, fine-tuning, augmentation, and reasoning strategies. Finally, teleprompters in DSPy automate the process of manual prompt engineering. They optimize the prompts used by the language model based on the program created using signatures and modules. This automation reduces the need for trial and error in designing prompts, making the development process more efficient and less sensitive to variations in prompts. By combining these elements, DSPy streamlines the development of LM-based applications, allowing developers to focus on the functionality of their programs rather than spending time fine-tuning prompts. This approach helps in reducing sensitivity to prompt variations and enhances the overall robustness of the applications built using DSPy.
It's impressive how DSPy leverages signatures, modules, and teleprompters to streamline the development process of LM-based applications, effectively reducing sensitivity to prompt variations. Signatures serve as high-level instructions for the language model, abstracting the input-output relationships and allowing developers to focus on programming logic. Modules offer a flexible way to apply different prompting techniques to adapt signatures to various tasks, enhancing customization and automation in prompt handling. Teleprompters play a crucial role in automating prompt optimization, optimizing the prompts used by the language model based on the program's specifications, and minimizing manual tweaking. This integrated approach in DSPy not only simplifies the development workflow, but also enhances the robustness and efficiency of LM-based applications by minimizing the impact of prompt variations. By prioritizing programming and automation over manual prompt engineering, DSPy offers a promising framework for the generative AI community, aligning with the shift towards more systematic and reliable application development using large language models.
DSPy utilizes signatures, modules, and teleprompters to streamline the development process of LM-based applications and reduce sensitivity to prompt variations by abstracting away the complexities of handcrafting prompts and fine-tuning in traditional language model-based pipelines. 1. Signatures. In DSPy, every call to the language model must have a natural language signature. These signatures act as a guide for the model, specifying what transformation is needed without getting into the nitty-gritty details of how to prompt the language model. For example, a signature could be as simple as question-answer or long document summary. This abstraction simplifies the development process by focusing on the task at hand rather than on the specifics of prompting. 2. Modules. DSPy abstracts prompting techniques into modules. These modules encapsulate the logic required to interact with the language model based on the defined signatures. By modularizing prompting techniques, developers can focus on composing these modules to build more complex applications without worrying about the intricacies of prompt engineering. 3. Teleprompters. DSPy automates the process of prompting for arbitrary pipelines using teleprompters. These teleprompters optimize the program by maximizing a given metric, e.g., improving quality or reducing cost for the specific task at hand. By automating prompt engineering, DSPy reduces the manual effort required to fine-tune language models and ensures consistency and efficiency in the development process. Overall, DSPy's use of signatures, modules, and teleprompters simplifies the development of LM-based applications, minimizes sensitivity to prompt variations, and shifts the focus towards programming and away from manual prompt manipulation.
The incorporation of signatures, modules, and teleprompters in DSPy demonstrates a systematic and sophisticated approach to developing LM-based applications while addressing the prompt sensitivity problem. Signatures provide a high-level guide for interactions with the language model, abstracting the specific prompting details and enabling developers to concentrate on the task's requirements. Modules in DSPy encapsulate prompting techniques, enabling developers to compose complex applications by leveraging predefined logic without the need for intricate prompt engineering. Teleprompters in DSPy automate the process of prompting in diverse pipelines by optimizing programs based on specific metrics, such as improving quality or reducing costs. This automation streamlines the prompt engineering process, reducing manual intervention and ensuring consistency and efficiency in developing LM-based applications. By emphasizing programming and automation over manual prompt manipulation, DSPy enhances the overall development workflow, reduces sensitivity to prompt variations, and simplifies the creation of robust LM-based applications.
DSPy's integration of signatures, modules, and teleprompters streamlines the development process of LM-based applications by focusing on programming and automation rather than manual prompt manipulation. Here's how it works. 1. Signatures. By using signatures, which are short functions that specify what a transformation does rather than how to prompt the LM, DSPy eliminates the need for handwritten prompts. These signatures abstract the prompting and fine-tuning process, making it easier to understand the purpose of each step in the program without getting caught up in the specifics of how to prompt the LM. 2. Modules. DSPy abstracts prompting techniques, such as chain of thought or React, into modules. These modules provide a higher level of organization to the program, making it easier to manage and modify different prompting techniques without affecting the entire pipeline. This abstraction reduces the sensitivity to prompt variations because changes can be made at the module level rather than having to manually adjust each prompt. 3. Teleprompters. DSPy automates prompting for arbitrary pipelines using teleprompters. These teleprompters optimize the prompt generation process based on the program's structure and requirements. By automating prompt engineering, DSPy reduces the need for manual intervention in adjusting prompts, which in turn decreases the sensitivity to prompt variations caused by changes in components like the LM or data. In summary, DSPy's integration of signatures, modules, and teleprompters simplifies the development of LM-based applications by emphasizing programming concepts, automation, and abstracting prompt manipulation. This approach reduces the fragility of LM-based applications by minimizing the impact of prompt variations, ultimately making the development process more efficient and less error-prone.
The synergy of signatures, modules, and teleprompters within DSPy revolutionizes the development of LM-based applications by prioritizing programming and automation over manual prompt manipulation. Signatures serve as succinct functions that define transformations without delving into the specifics of prompting the LM, streamlining the understanding of program logic and eliminating the need for handcrafted prompts. Modules in DSPy abstract prompting techniques into organized units, facilitating the management and customization of prompting strategies without disrupting the entire application pipeline. This modular approach enhances robustness by enabling targeted changes at the module level, reducing sensitivity to prompt variations that may arise from manual adjustments. Teleprompters in DSPy automate prompt generation for diverse pipelines, optimizing prompts based on program structure and requirements. By automating prompt engineering, DSPy minimizes the manual intervention needed for prompt adjustments, consequently mitigating the sensitivity to prompt variations caused by changes in LM components or data sources. In essence, DSPy's holistic use of signatures, modules, and teleprompters simplifies LM-based application development through a focus on programming principles, automation, and abstracted prompt manipulation. This strategic emphasis not only enhances development efficiency, but also fortifies application robustness by diminishing the impact of prompt variations, ensuring a more reliable and streamlined development process.